Hello folks. So in this video, we're going to be looking at time series. So time series data and then time series databases. Okay, so this is a very introductory video and we're just going to be looking at some very basic stuff. And I know some idea about time series data and I just want to actually walk through the whole thing from basics from scratch, and then give you an idea about what time series is and what time series databases are there, services are there out there. So let's get started. Let's get to my browser first. So that's my browser. Okay, so let's just type out time series and then see what it says. So it says, let's close this off. So we have some Wikipedia stuff over here. So let's just see. It says in mathematics, a time series is a series of data points indexed in time order. Most commonly, a time series is a sequence taken at successive, equally spaced points in time. Thus, it is a sequence of discrete time data. Examples, it's ocean tides, counts of sunspots, daily closing value of Dow Jones industrial average, and whatnot. So if you read this whole thing, you'll understand that time series is kind of like a you can plot it like a graph. Like if you take those data, the time series data, and the data looks something like this. Like you have some sort of value that you're looking at, and then you uh, you actually take up the value. You actually find the value at different points in time. For example, let's say now it's 10 a.m. now, and then I take up a value. Let's say, you know, the CPU usage in my computer. Okay, so this is a value that keeps changing, right? It's not a constant. The CPU usage at this point in time might be a bit more because I'm using a lot of softwares, but maybe let's say I close all of them, then the CPU usage is less. So over time, it can vary, though it doesn't have to, but it can vary very easily. So then now what I do is at 10 a.m. my CPU usage is, let's say, 50%. And then I take the data point of what the value of my CPU usage is at, say, 10:15, and then 10:20, and then say, or 10:15, and then 10:30, and then 10:45, and then 11, and it goes on. So I have a series of data points where I can say, hey, the value of my CPU usage at this time is this. And then the value of the CPU usage at this other time is this. And then it goes on. So it's a value against time. And you can actually plot it over a graph where one axis of the graph is time. So the time just keeps increasing. And then there is a value axis where there's like different sets of values. And then you can plot a graph and then you can see how the value changes over time. Does it go up, go down, or is it constant and whatnot, right? Usually it's varying and not a constant usually. And that's why you actually pick up the value at various points in time. And if you keep getting it very quickly, like say 10 and then 10 1, or say 10 and then 10 1 second and then 10 2 seconds, that's like pretty close. So you'll have some sort of like interval between every time you take. So it depends on what application or what kind of value you're picking up and how frequently that value changes. For example, the CPU usage of my computer is not going to change every second. I mean, it could, but it's not going to change very drastically. Like it won't be like 50% and then 90% in a second. Like that's rare. So it can't shoot up so fast in a second, I guess. It's just a guess, but so I'm saying like you don't have to. I mean, that's going to be still, if even if it's possible, that's going to be rare. So you can probably take it every minute or every 15 minutes, and then that is like your sampling time or whatever, right? Your interval time. So with this, so why do we do this, right? So with time series, you can actually, since I said you have the data or a value over time, you can actually do some analysis. For example, let's say you have the CPU usage data. Let's say this is the CPU usage of your microservice in say in production. You can understand at what points in time the CPU usage spikes, right? To understand what is say why is it spiking. For example, one reason that it could be spiking is because there's a lot of requests coming to your microservices because there are like a lot of users using the your product, which in turn is using the microservice. So you need to understand that like time series is just like a concept, and it could be used in various places. This is just one example. And when I say various places, for example, this doesn't have to be CPU usage. This can also be something like, say, weather temperature data, right? Your IoT sensors that can sense anything, temperature, or say anything, right? Say pressure in some place or whatever, right? So IoT sensors, any IoT kind of application where there's like a lot of data that's coming in every moment, all those data is like the value, and then you have that moment, that time, and then you can put all this data as a time series, and then you can plot graphs. You can find out some data, like information from that, say the average data over some point in time, and then things like the maximum, of course, but that's, however, that's going to be there without the time factor. But if you have the time, you can also find out the average within a given time interval. Say in a week, what's the average weather temperature, right, and things like that. And you can also, of course, use it in applications like, say, your when you're monitoring or observing your production environment, when you have some service running. You can look at the CPU usage, memory usage. You can look at business metrics, like how many users are present at any given point in time. And then you can look at, say, how many HTTP requests are coming at any point in time, right? There's like a lot of different use cases in computer science for like the kind of data that we can use for time series, and like how we can use it to, say, plot graphs, analyze the data from, like, analyze things from it, get insights and all that, right? And also take decisions or understand issues from that. So time series is a pretty interesting thing like that. So let's go back to my browser, and we're going to look at how there are like a lot of time series databases. So let's just type in and see if we can find out from the search engine. So there are like okay, so cool. So there are like a lot of articles around time series databases. So I'm gonna actually list out some time series databases, and then like we'll look at like others also from this, say, from this list, right? So one example of time series database is like Timescale, which is actually a Postgres extension. So it's Postgres plus time series. So it's a Postgres extension. So you are not exactly having a database that is built from scratch. Uh, Instead, it's Postgres itself that has been built long ago and has been in production and has been in usage for like decades now, and has been battle tested, and like has been run in production a lot of times by a lot of people. And there are various versions of PostgreSQL too, and there are like, it's still being in use, right? So the thing to understand here is that in Timescale, it's a Postgres extension, and you are using Postgres. It's not like a database that does only time series. You're using Postgres that can do relational database. That's a relational database, and that can do relational tables and relational databases and all that. And with Timescale, you get your time series, right? So now this is one example of it. There are some more examples. For example, this Prometheus .io. This is a monitoring system, and it's a time series database. So it's you can see this here, monitoring system and time series database. It's very popular in the monitoring domain. It's a very popular open source project. Actually, even Timescale is open source. There's also an enterprise edition. And so the thing is this, right? Like here, you can find out all the features of these, time series databases. I'm not going to go into them, but it will be interesting for you to actually check out what actually they provide, right? For example, Prometheus, markets themselves as a monitoring system and time series database. At the core, yes, it's a time series database, but it's also like popular for being a monitoring system, and it has integrations with other, say, um, like software to do other stuff. For example, it has integration with this thing called Alert Manager, which is a software in its ecosystem, in the ecosystem of Prometheus, to actually send alerts to different channels like, say, Slack, PagerDuty, and whatnot, right? Let me find out if I can actually get hold of it. So this alerting. So it can do alerts. Prometheus can do alerts, but it can't send it to say other channels. It instead sends it to Alert Manager, which has integration with channels like Slack and whatnot. And let's see if I can actually find out. Some more details are here. Okay, it went into the repo itself. But you can go and check out how there's a configuration to actually send alerts to say, for example, email and then pager duty and whatnot, right? So this is going into the details of like alert manager and whatnot. But I just wanted to call this out, like it's time series database and it's like popular in the monitoring. So time series, one of the use cases is like getting metrics, especially monitoring metrics, or even something like business metrics, or any metrics that you have, where a metric is like a data. Again, it's basically a time series data, basically, where you have data and then there is a overtime data overtime, basically, right? So metrics change basically. Right? So this is one example, and then there is more examples like say InfluxDB. So there's this thing called Influx. So yeah, this is also open source, and there's also a closed source version. So there's Influx, and then there is this company called Graphite. Let's look at that. Graphite database. I think this is the one. Yep. So time series database. So you have Graphite, and then you have this thing called OpenTSDB, which is TS is short for time series, so OpenTSDB. And then there are more like these, right? So it's pretty interesting to look at the different kinds of databases that are available for time series data. It's interesting to note that I mean, I've seen only Timestream to be the one built on top of an existing database like Postgres. I think everything else is like built from scratch, but has integrations with some stuff. But yeah, it's not like an existing database and then they changed it in some ways, or at least nothing that I know of. So looks like, for example, this one runs on Hadoop and HBase. Okay. So each has its own like use case and whatnot. So yeah, uh, and you can also, of course, look at the different list over here, like say Amazon Timestream, which is a managed time series database. I don't know what is Amazon time series. You can look at it. So, and then there's this thing called Druid, which is a time series database. You can see timescale. You can see Azure time series insights. QuestDB. I haven't heard of many of these. I mean, it's just checked out Prometheus. There's KDB, and then there's Influx. Of course, we notice that. We know. I mean, React is a bit popular. I think many might know it. It's a NoSQL database, and so yeah, there are like a lot of these. Let's look at probably even Druid, and then like we can move on to like so there's Graphite and like Pyros, great. Okay, let's look at Druid, and then we can move on. So Druid is basically Apache Druid, and it's a real-time database to power modern analytics applications. It says. So let's look at if it supports like time series. So it doesn't talk about time series in their web page, but I think it can be used for time series. Use cases, let's look at it. Time, real time, Druid. Yeah, so metrics, right? So Druid can be used as a time series solution for server and device metrics. In just machine generated data, for example, like CPU usage and all that is like machine generated. Like it can generate the data, or it can understand how much it's using, and then send it in like IoT or device metrics, etc. In real time and perform rapid ad hoc analytics to measure performance and all that, right? So these people boast that they are a analytics engine at heart. So they combine ideas of like time series databases, column oriented. So it's a column oriented database, Druid, and then like search systems and whatnot, and it supports time based partitioning and like time based queries and whatnot, right? So it's a pretty interesting database. And there's actually this one company called Signals, and it's a product too, which actually uses Druid. So you can actually check this out. So it does application performance monitoring, and they internally use Druid. For example, let's look at, say, getting started for free, and then say user guide, or once tutorial technical architecture. um okay, so this one talks about Clickhouse as a thing. I'm not sure if it has Druid. Let me check out. I think they don't support Druid now, but I'm assuming they don't. Um, Anyways, I think they used to have Druid, Apache Druid, apart from ClickHouse, but now I think they don't. That's interesting. Okay. Anyways, so ClickHouse is also a column-oriented database, and I think ClickHouse can be used for, you know, so let's just go clickhouse.tech. Okay, clickhouse.com. So Yandex actually has created a ClickHouse company, and ClickHouse was already a project too. And it's a columnar or column database, and it's also analytical, online analytical processing database, not instead of transaction. And it is for real-time analytics. And let's look at use cases. Maybe do we have use cases? They don't have use cases, but yeah, I think it could be used for time series. It could be used as time series, but I'm not sure really. So it's something to check out, but I'm assuming you could do something like that. So yeah, that's that. And then finally, we are going to look at this, yeah, Amazon Timestream. That's it. I think everything else you could go check it out yourself. But let's check out Amazon Timestream. I think it's a managed service of Prometheus. It's a managed Prometheus, but I'm not sure. It could be something else. But I think Amazon has a separate managed Prometheus. Let's check it out. It is Prometheus. Okay, it's not Prometheus. So it's not Prometheus. Let's see if Amazon Prometheus. Okay, so Amazon has a separate managed service for Prometheus. So this is separate Amazon managed service for Prometheus. So this is of course going to be helpful for your time series stuff, or basically say so you can see how it talks about time series metrics and all that. You can use it for your time series stuff and like metrics and like monitoring system. But they also have time stream, and it's a serverless time series database. That's awesome. So yeah, you can check this out. But I think this is all closed source. I don't think this is going to be out there, right? So, but it's an interesting thing. Um, so yeah, you can actually check this out, and yeah, you can use it and like. But yeah, you might have to pay for this, unlike the others, OpenTSDB, Graphite, Influx. Influx has an open source version and a closed source thing. You can use the open source one with some limited features. Right. So that's all I wanted to talk about in this video, talk about time series and then talk about the different kinds of databases that are out there for time series. There's actually more. I just spoke about a few of them that I know about or I've heard of. You can also check out more of them from, say, this list on trustradius.com, or like there should be a bigger list. I think this might be a smaller one. But some of these are pretty popular, some of these databases, and like a lot of people use it. So you should be able to like find it out and like play with it. So I'll create a separate video on using different databases. For example, I'll probably start with say timescale and then move on to the others. Yeah, but for this video, that's all. Thanks for watching, and I'll see you in the next one. Bye bye.